Hey, well, good evening. Here we are in video 4 now. We're going to go into a little bit of detail on SARSA and Monte Carlo. I thought we'd start first with looking at reviewing the Q learning because that's something we've already done from the previous set of videos. Put in some detail on it. So I just want to notice the structure. So these end counters and win counter, those are um, um, stuff I use for problems troubleshooting. So anyway, but here's where it starts a new episode, initializes that visited state, so we can use that in the rewards or punishers. Then it starts with state one. Okay, in this while loop, this is where the each episode starts running. Action to zero right away. It chose an action based upon epsilon. Basically, starting out, it's going to say 999 times up to 1,000. I want to be exploring, trying something new, something random. And then once in 1,000, trying actually what the Pew table says I should be doing. This gradually goes down. We'll see that in a second. Never mind that. Okay, so then it finds the next state and starts finding the reward. And this one, and this also helps with the reward, a negative reward if it visits a state, positive if not. Uh, then this is penalizing slightly for if they're jumping. And this one's figured out whether it's in. If we're in the falls off one end or the other, it's going to end the game, end the episode. Or if we've picked up all three coins, it's going to give a huge reward and end this episode also. And then either way, it uses the Bellman equation to calculate what the value should be for that Q table, that state in the Q table. And then it goes on to the next state. It keeps going round and round and around until it hits one of those ends. And then notice after that episode is done, it decays the epsilon a little bit. Then it goes back up and starts the next episode. Starts right here, starts the next episode, goes through it again, and does that 1,000 times. That's Q learning. So I want you to remember that because we're going to go up and look at SARSA now, and it looks a lot the same. So here's SARSA. Starts out the same way, initializes state, so on. Finds the current action of the state one, which we did a different way in the Q learning, but it's the same kind of thing. Then it finds the next state, finds a reward. Notice the same rewards for whether you visited a state previously or not. Whether or not if you're jumping, a minor reward. And then if you fell off the end, you were done. And if you collected all the coins, you get a big reward. It's not quite as big as the other ones. Remember I did that. Then it chooses the next action. And then where the other one had the Bellman equation, this is a lot like the Bellman equation. But it's just another way to calculate what's the value of the action and state and action of the one we're just leaving. Then it goes on to the next state, finds the next action. Notice there is no, so it went through this until it's done. And notice when it leaves, it doesn't change the epsilon. We'll get back to what's going on there in a minute. So it just goes and does another one. So that was SARSA. Now we're going down and take a look at Monte Carlo. There's Monte Carlo. It's going to look similar also. Here we are. Here's where it starts. Here's where the episode starts. Initialize, initialize, initialize. And we have something new right here in line 348, episode history. We'll get into that. Okay, well, not done. So first off, we find the next action. You choose the action for it. Then we transition, find the next state, start the reward process again. It's the exact same set of rewards, for the visited states, for the jumping, for when you're done or not, and the if you've got all the coins. Then here's what comes in. Episode history. We append that state action reward. So this episode history is made up of, it's a array made up of 3-element arrays, recording all the state action rewards. And it goes on to the next state. Keeps doing that until it gets it done. And notice what it didn't do is it didn't calculate what goes on. What should I replace the Q table with? What should the state and action value in the Q table? How should I? It doesn't say. It just keeps on going on. It keeps collecting the state action rewards. Then at the end of the episode, then it does this update Q table from episode history. So it looks at all the episodes at one time and goes ahead and does the calculation and updates the Q table. And this is that function there. Excuse me. And what it does is looks at the episode histories, looks at the various parts of it, looks at them backwards, does a kind of an averaging sort of thing. And then down here, right here, is where it actually updates the state and action in the Q table. So it's fascinating the way it does it. So it's a lot of stuff the same. Certainly I could have done this whole section on rewards. Could have easily been a separate class, but I chose to leave it this way so you can see all the details. So that's those three, and now I want to go a bit of a review on these. So Q learning, comparing Q learning, SARSA, and Monte Carlo, and I'll talk a little bit about DQN now too. So on policy, what that means is this training method using the policy itself and doing exactly what the policy says? Namely, for any given state, the policy's got some numbers in it. Let's take a quick look at that. I should show you that too. So here's a policy. Like if you looked at state 1, moving left is minus 17, jumping left is minus 23, moving right is plus 36, and jumping right is plus 76. So policy says jump right, and so on down through there. So back to this now. So on policy, these guys, these two, use the policy exactly. 9 times out of 10, they'll say, I want to do exactly what the policy tells me to do. So I'm not going to explore very much. Q learning, on the other hand, says, it starts out saying, whoa, wait a minute, 999 times out of 1,000, I'm just going to random guess. And then 1 time out of 1,000, I'll do what the policy tells me to do. So it's off policy. We're going to find DQN works the same way. It's also off policy. So this is explaining that a little bit more. The way the epsilon works and the Q learning works, it starts out mostly exploring and then slowly decays that epsilon until it's mostly exploiting. SARSA and Monte Carlo are almost always exploiting, and DQN does the same thing as Q learning, deep Q learning, it makes sense. Starts out mostly random, mostly exploration, and then gradually makes it down to mostly exploiting. Okay, the other property I want to look at is, does it update every state? You saw the way the calculations were. Q learning did that Bellman equation and updated the current action state in action right away, just before it left to the next state. SARSA did the same thing. Monte Carlo didn't, but Monte Carlo, it kept those numbers, but didn't update the states until after it was done with the whole entire episode. You'll find when we get there to DQN, it actually doesn't update every time either, and it also doesn't update at the end of an episode. The way the project I have it set up right now is it updates every 32 times it goes through the state action sequence. We'll get into that later though, and look at the details. And finally, does it create the Q table directly? Now, while Q learning doesn't actually use the Q table directly as is, it actually updates it every single time. So yes, it is keeping that Q table right in the learning. SARSA, same thing, keeps that Q table. And the Monte Carlo, even though it updates it at the end of every episode, still their Q table is always there to look at. DQN, there is no Q table. That's the amazing thing, that's like, how does this work if there's no Q table at all? But we'll get into that over the next video. So anyway, so that's where we are right now with looking at agent underscore Q learning dot GD. For the next one, we're actually going to start looking at the DQN. We'll spend a few videos doing that. So thank you. Take care. Bye.